Mars has long fascinated humanity, inspiring countless stories and scientific missions. In this section, we will explore the realities of traveling to the Red Planet, delving into the journey itself, the complex process of landing, and the formidable challenges of survival. Unlike science fiction, a real mission to Mars demands careful planning, advanced technology, and resilience against harsh conditions. From the months-long voyage through space to the perilous descent onto the Martian surface, each stage presents unique obstacles. Once on Mars, explorers must contend with extreme temperatures, limited resources, and a thin atmosphere. Understanding these challenges is essential for anyone interested in the future of interplanetary exploration. Mars, often referred to as the Red Planet, is the fourth planet from the Sun in our solar system. Its striking reddish appearance comes from iron oxide, or rust, that covers much of its surface. Mars is home to towering volcanoes, vast canyons, and polar ice caps, offering a landscape both familiar and alien. The planet's thin atmosphere is composed mostly of carbon dioxide, resulting in extreme temperature fluctuations and a harsh, dry climate. Despite these challenges, Mars has long fascinated scientists and explorers due to evidence of ancient riverbeds and the possibility that it once harbored liquid water. Its relative proximity to Earth and the potential for past or present life make Mars a prime target for ongoing exploration and future human missions. These unique features continue to inspire humanity's quest to unlock the secrets of our neighboring world. Humanity's desire to conquer Mars is driven by several compelling motivations. Scientific curiosity plays a major role, as exploring the Red Planet could reveal valuable insights about the origins of our solar system and the possibility of life beyond Earth. The ambition to expand our living territory also inspires this quest, offering a potential solution to future challenges such as overpopulation or resource scarcity. Additionally, the journey to Mars pushes the boundaries of technology, fostering innovation in fields like robotics, artificial intelligence, and sustainable energy. Together, these factors fuel our determination to reach and eventually inhabit Mars, marking a new chapter in human exploration. Preparing for a journey to Mars demands rigorous attention to technology, health, and psychological readiness. The crew must undergo extensive training to operate advanced spacecraft systems and life support equipment, ensuring they can handle emergencies and routine maintenance far from Earth. Health screenings are essential, as only individuals in peak physical condition are selected, and they must be prepared for the effects of microgravity and radiation exposure. Psychological resilience is equally important, with astronauts participating in simulations and counseling to cope with isolation, confined spaces, and the stress of long-duration missions. Specialized diets and exercise regimens are developed to maintain strength and well-being during the voyage. Every aspect of preparation is meticulously planned to maximize safety and success on the challenging journey to Mars. Interplanetary travel relies on advanced spacecraft and propulsion technologies designed to overcome the vast distances between planets. Modern spacecraft are equipped with powerful engines, such as chemical rockets for initial launch and ion thrusters for efficient long-duration travel. Some missions utilize nuclear thermal propulsion, which offers higher efficiency and speed compared to conventional chemical engines. Reusable launch vehicles and modular spacecraft designs also contribute to the practicality and cost-effectiveness of interplanetary journeys. Innovations like autonomous navigation systems and radiation shielding ensure both safety and reliability during transit. These technological advancements are paving the way for more frequent and sustainable missions beyond Earth, bringing the dream of exploring other planets closer to reality. The journey to Mars unfolds in several distinct stages. It begins with the launch from Earth, as a powerful rocket propels the spacecraft beyond our planet's atmosphere and into space. Once free from Earth's gravitational pull, the craft enters the vast expanse of deep space, traveling millions of kilometers on a carefully calculated trajectory. During this phase, astronauts must rely on advanced life support systems and precise navigation to ensure their safety and progress. As the spacecraft nears Mars, it must execute a series of complex maneuvers to slow down and align with the planet's orbit. Successfully entering Martian orbit marks a critical milestone, setting the stage for the next steps of descent and landing on the Red Planet. Space travel to Mars presents a range of significant risks that must be carefully managed. One major concern is exposure to cosmic radiation, which can increase the likelihood of cancer and other health issues due to the lack of Earth's protective atmosphere. The possibility of colliding with micrometeoroids or larger space debris also poses a threat to both the spacecraft and its crew. In addition to physical dangers, astronauts face psychological challenges from prolonged isolation, confinement, and separation from Earth. These factors can lead to stress, anxiety, and even depression over the course of a long mission. Addressing these risks requires advanced technology, rigorous planning, and robust support systems to ensure the safety and well-being of everyone on board. Landing on Mars presents a unique set of challenges due to its thin atmosphere and unpredictable surface conditions. Spacecraft rely on a combination of heat shields, parachutes, and retro rockets to slow their descent as they approach the planet. Advanced guidance systems and radar help navigate the final moments, ensuring the lander avoids hazardous terrain such as rocks or steep slopes. Engineers often use airbags or specialized landing legs to cushion the impact and stabilize the craft upon touchdown. Each mission must carefully calculate entry angles and timing to maximize safety. These techniques and technologies have evolved over decades, allowing for increasingly precise and successful landings on the Red Planet. Upon arrival on Mars, explorers are immediately confronted by a landscape that is both rugged and unpredictable. The planet's surface is littered with rocks, steep slopes, and uneven terrain, making movement and navigation a significant challenge. Fine Martian dust, pervasive and easily stirred by the wind, can infiltrate equipment and pose risks to both machinery and human health. Weather conditions add another layer of difficulty, with sudden dust storms and extreme temperature fluctuations that can threaten safety and disrupt daily operations. Adapting to these harsh elements requires careful planning, robust technology, and a deep understanding of the Martian environment. Each step forward is a test of resilience and ingenuity in the face of nature's formidable obstacles. Establishing a base on Mars requires careful planning and consideration. The crew must select a location that offers both safety and access to essential resources, such as water ice and protection from harsh environmental conditions. Building the habitat involves assembling modules designed to withstand extreme temperatures, radiation, and dust storms. The site should be stable, away from steep slopes or potential landslides, and ideally situated near natural features that can provide shielding. Ensuring the base is secure is crucial for the crew's survival, with redundant life support systems and emergency shelters in place. Thoughtful layout of living, working, and storage areas helps maintain efficiency and morale during extended missions. Survival in a closed environment requires careful management of essential resources. Finding and securing a reliable source of water is a top priority, often achieved through recycling systems or extracting moisture from the air. Food production can be sustained by cultivating crops in hydroponic or aeroponic systems, which maximize yield while minimizing resource use. Maintaining clean air is equally vital, typically accomplished by using advanced filtration systems and growing plants that help regulate oxygen and carbon dioxide levels. These integrated solutions work together to create a stable environment, ensuring the health and safety of inhabitants over extended periods. Each element must be continuously monitored and adjusted to respond to changing conditions and potential challenges. Effective management of energy and resources is crucial for sustaining long-term life in remote or challenging environments. Harnessing solar energy provides a reliable and renewable power source, reducing dependence on traditional fuels. Recycling materials not only minimizes waste, but also allows for the creation of new tools and infrastructure from existing resources. By optimizing the use of available supplies, communities can ensure that essential needs are met without exhausting their environment. These strategies collectively support a sustainable lifestyle, enabling inhabitants to thrive even in isolated or harsh conditions. Communicating with Earth from distant locations such as Mars presents significant challenges. The vast distance causes a noticeable delay in signal transmission, with messages taking anywhere from several minutes to over 20 minutes to travel one way. This latency makes real-time conversations impossible and requires careful planning for mission operations. In addition, maintaining a stable connection is complicated by factors like solar interference and the need for powerful transmission equipment. To address these issues, engineers have developed advanced relay satellites and automated systems that can operate independently when immediate guidance from Earth is unavailable. These technological solutions help ensure that vital information can be exchanged even across the immense void of space. Exploration and research on the surface of Mars involve a variety of scientific activities. Teams conduct surveys to map the terrain, analyze geological features, and identify areas of interest. Sample collection is a crucial part of these missions, with researchers gathering soil, rock, and atmospheric specimens to study Mars's composition and history. Advanced instruments are used to detect signs of water, measure radiation levels, and search for potential traces of past life. These investigations help scientists understand the planet's climate, geology, and potential for supporting future human missions. Through careful observation and experimentation, each discovery brings us closer to unraveling the mysteries of Mars. Isolation can have a profound psychological impact, especially in remote or challenging environments. Feelings of loneliness, anxiety, and stress often arise when individuals are cut off from familiar social networks. To support mental well-being, it is important to implement strategies such as regular group discussions, shared activities, and open communication channels. Encouraging team members to express their thoughts and emotions helps foster trust and understanding. Maintaining routines and celebrating small achievements can also boost morale. By prioritizing emotional support and group cohesion, even small, isolated teams can remain resilient and connected. In emergency scenarios, swift and effective responses are crucial for survival. Equipment malfunctions can threaten vital systems, requiring immediate troubleshooting and repair to prevent further complications. Resource shortages, such as a lack of water, food, or oxygen, demand careful rationing and creative solutions to stretch supplies until help arrives or the issue is resolved. Medical emergencies, ranging from injuries to sudden illnesses, must be addressed using available first aid knowledge and limited medical resources. Communication with support teams, if possible, can provide guidance and reassurance. Maintaining composure and following established emergency protocols can significantly improve outcomes in these high-risk situations. The future of settling on Mars holds remarkable potential for human expansion beyond Earth. As technology advances, the possibility of building sustainable communities on the Red Planet becomes increasingly realistic. Innovations in habitat construction, life support systems, and resource utilization are paving the way for long-term habitation. Scientists and engineers are developing solutions to challenges such as radiation protection, food production, and reliable energy sources. Over time, these efforts could lead to thriving Martian settlements, fostering a new era of exploration and cooperation. The vision includes not only survival, but also the growth of vibrant societies, where people can live, work, and contribute to a shared future on Mars. Over the years, numerous missions to Mars have provided valuable lessons for future exploration. Early successes, such as the Mars Pathfinder and the Spirit and Opportunity rovers, demonstrated the importance of robust engineering and adaptability in harsh environments. However, several missions have also faced setbacks, including failed landings and communication losses, highlighting the challenges of interplanetary travel and the need for meticulous planning. Achievements like the discovery of water ice and evidence of ancient riverbeds have deepened our understanding of Mars' potential to support life. Each mission has contributed to refining landing techniques, improving autonomous navigation, and enhancing scientific instruments. These cumulative experiences continue to shape the strategies and technologies used in current and future Mars exploration efforts. The conquest of Mars holds profound significance for humanity, touching on scientific, social, and future-oriented dimensions. Scientifically, exploring Mars could unlock answers about the origins of life, planetary evolution, and the potential for life beyond Earth. Socially, the challenge of reaching and inhabiting Mars inspires global collaboration, technological innovation, and a renewed sense of curiosity and ambition. The endeavor pushes the boundaries of what is possible, encouraging advancements in fields such as engineering, medicine, and environmental science. Looking ahead, establishing a human presence on Mars may offer a safeguard for our species, providing a backup habitat in case of catastrophic events on Earth. Ultimately, the journey to Mars represents a bold step toward shaping the destiny of humankind and expanding our place in the universe. Reflecting on the journey to Mars, it becomes clear that the challenges faced are as immense as the opportunities that await. From the perilous voyage through space to the complexities of landing and establishing life on a distant planet, each step demands innovation and resilience. Yet these obstacles also inspire groundbreaking advancements in technology, science, and human cooperation. The pursuit of survival on Mars pushes the boundaries of what is possible, fostering a spirit of exploration that could redefine our future. As we continue to learn and adapt, the dream of thriving on Mars transforms from a distant vision into a tangible goal, opening new horizons for humanity.